look at how to find out the voltage and current in this circuit using Kirchhoff's voltage law and Kirchhoff's current law. Now let's look at this one. So for the first one, what is the current here? I mean, here we have the current and we have the resistance. What's the voltage across this resistance? For this one, we can use the Ohm's law, that is V is equal to I times R, and we already know the current and we also know the resistance. So this is 5 times 8, that is 40 voltage. So the voltage across this resistor is going to be 40 voltage. Okay, and let's put plus minus also. Plus minus minus. Okay, so this is 40 voltage. Let's call this one V1. So V1 is equal to 40 voltage. Now we know the current through this resistor. The next thing we can find is we can also find the current. We don't know the current across this resistor, and also we don't know the voltage here as well. So for this one, voltage is a little bit easier because we have all the voltage in a loop. So if we have two voltage known and if one is unknown, if we have a one voltage unknown in a circuit, a loop, we can apply KVL to find it out. So I'm gonna apply KVL, and let's call this one loop 1. Okay, KVL at loop 1. So KVL says that addition of all the voltage is equal to 0. So let's assume the current is flowing in this direction. Let's call this one I1 or I. Okay, I current flow in this direction. So first you can see this current actually going from negative to positive. So we can say minus 60. And here the current is going from positive to negative. So that is plus 40. And this one also, if we go through this current direction, this one also goes from plus to minus. So this also positive. Let's call this voltage V2. This is V2. That's what we are trying to find. That's equal to 0. So minus 60 plus 40, that is minus 20. That is V2, 0. Therefore V2 is equal to 20 voltage. So we found out the V2 voltage. Now let's look at what are the things we still didn't find. We didn't find this current. Let's call this current I2. So if I want to find this current, I can apply Ohm's law. V is equal to IR. So I is equal to V divided by R. I2 is equal to V2 divided by R. R2, let's call this R. That is V2 already found, 10 ohm. Actually V2 20 volt divided by the R2, that is 10 ohm. So that's going to give us 2 ampere. So the current passing through this one is 2 ampere. Now what is unknown here now? Now we have this current and okay, so we have this current, this voltage. So we actually completed this whole loop. We know the resistor, current, and the voltage across all of them. Now let's go to the next loop. Here we have 4 ohm. We don't know the voltage and we don't know the current. Voltage, we have two unknown voltage. Like we don't know this voltage and we don't know this voltage. So better to do with the current, because since we have a node right here, you can see the node. We know the current entering the node in one point, and also we know the I2 that's exiting the node. So if I apply KCL at that node, so let's call this one node 1. Okay, KCL at node 1. If I apply, KCL says all the current addition of current is equal to 0, or you can say current sum of current in is equal to sum of current out. Both of them are correct. Now sum of current in, 5 ampere is entering, or you can say addition of all the current is equal to 0. That's also comes under KCL. That's easier to apply. Addition of all the current is equal to 0. So here we know 5 ampere is entering, and we know that I2 is exiting, so that is minus 2 ampere, plus let's call this current I3 across this resistor. So plus I3 should be equal to 0. So 5 ampere minus 2, that is 3 ampere. 3 ampere, let me use a different. 3 ampere plus I3 is equal to 0. Therefore I3 is equal to negative 3 ampere. This negative means the current is going out of the circuit, so current direction is this way, and that is 3 ampere. Okay, now we solve for the current here. The next thing we can find is, okay, since we have a current and the resistance, we can find the voltage here. Voltage at V3. Let's call this one V3. V3 across this resistor. So V3 is going to be I3 times R according to Ohm's law. R3, let's call it R3. So I3 is just found out that's 3 ampere, and then R3 is 4 ohm. 3 times 4, 12 voltage. So now we have 2 voltage now. We know this voltage. We just found the V2 voltage that is here, and we have found out the V3 voltage that is here. We only know, let's call this voltage across this V4. We only don't know this voltage. So if I assume current is flowing in this direction, okay, then addition of all the voltage is equal to 0 according to Kirchhoff's voltage law. You know what, I'm gonna remove something. Make sure you note these things. I'm gonna remove it because I need some space. I need the V2, so I'm gonna remove until this. Okay, let's continue here with a different color. Okay, so according to Kirchhoff's law, Kirchhoff's voltage law, addition of all the voltage is equal to 0. So we know the V2, that is 20 voltage, and we have to assume a current direction. Let's assume the current direction is this. So if it goes from minus to plus, that's minus 20, and again here it's plus to minus. So the V3 voltage is what? Plus to minus, that is plus 12 voltage. And V4 also is going from plus to minus, so that is plus V4, that is equal to 0, and minus 8 voltage is equal to plus V4 is equal to 0. Therefore V4 is equal to 8 voltage. Okay, now we found out the V4 voltage. Now we can find the current across this using the Ohm's law, that is V is equal to I times R. So I is equal to V divided by R. Let's call this one I4. V divided by R. Current here I4, and this 4. So V divided by R, V is, let's call this one V4 divided by R4. V4 is 8 voltage and the R4 is 2 ohm. So we're going to have the current 4 ampere passing through this resistor. Okay, now we have solved everything. Only thing we don't know is the Vx and Ix. Now the thing is, we have 8 voltage right here, right? We have 8 voltage right here, and we don't have any resistor in between. So exact same voltage is going to be the voltage X as well, because we don't have any resistance to slow the voltage. So the voltage here also is going to be exactly the same, that is 8 voltage. And Ix we can apply Kirchhoff's current law at this node. Kirchhoff's current law says all the addition of the current is equal to 0, and for I4, current passing through this direction because it's a positive current. And what was I for? 4 ampere. Okay, 4 ampere. So let's actually add them up. Ix, Ix is entering the node, so that's plus. And then 3 ampere is entering the node plus, and 4 ampere is exiting the node, so minus. So that is 3 minus 4 minus 1 ampere. So Ix is 1 ampere. 1 ampere. That's our final answer. Ix is equal to 1 ampere. That's it. We solved this circuit. That's how you can use KCL and KVL to solve any unknown value in a circuit. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.